Hello! We're on day 15, happy day 15 of the electronic sound advent calendar. And this is the build your own synthesizer advent calendar. So not just a advent calendar, but building a synth. And so far we've got this sound processor in here with an oscillator of some kind. But what have we got under door 15? Let's have a look. Oh. I have minced that door, and we have another capacitor. I wonder what we're going to do with this one. Let's go and have a look at the book. So today you get another ECAP electrolytic 100 UF to improve the operational reliability of the audio amplifier. Okay, so we're sticking this across from there to there. So it looks like what we're doing is adding one more jumper, and we're also there's a slight difference to the circuit here. Pay attention to the wires in column 23. Why does this, excuse me if I'm mistaken, but this looks different? Because we've got that pin there. Did that change in a previous point? No, this circuit is quite different, isn't it? So look, that's what we've got. That's what we're moving to. So we've got to move everything around a bit. Have we still got the same number of jumpers? We've got 1, 2, 3, 4, 5, and here we got 3, 4, 5, 6 jumpers. We've got a bit of stuff over there. Right, okay. Let's go make the first jumper, I guess. This time, I'm going to remember to strip a jumper wire length off. And we want about that long. This time I'm going to strip it from here, that way. There we go. It's just a bit easier to strip a jumper when it's still attached like that. Okay, form that up. I do have my pliers, I'm just being lazy. Right, this is quite a different circuit. Well, the big parts are staying where they are, the small parts are all moving around. Okay, so that goes in across here. There we go. And now we take that out. This one stretches between the middle pin of that and that pin between those two. We'll put it there like that. This resistor is now gone. In fact, so are the other two. So those resistors are all gone. And we have a length of wire. Hold on. That length of wire is gone. And right, we'll pull this one out. That one's still there. Those two, and that one's still there. We need one further length for there. Is this long enough for one of these? Can we repurpose it? I've just noticed this drawing is not to scale, so don't use the drawing to scale on anything. Actually, that's going to be easier going under this capacitor than over, I think. Okay, let's just lift that off, because so that's going to go across from the top there, that pin, and down to here. There we go. That goes in there nice and neat. Across the middle pin there, across that pin there. Okay, we've got that wire in, so we are going to need one more. It goes from here, no, here. So we'll leave a couple of millimeters, and that's pin 5, and again leave a couple of millimeters. there's some odd things going on there because they've no longer got pin 10 connected to ground. And maybe that, which was before connected to ground, look, there we go, pin 10 connected to ground, but not here. Maybe that actually is a signal for a particular way for this sound processor to function. Maybe pulling it down on that pin, and that goes back over here. So that possibly is a signal for what program this is running. There's probably a conditional that says based on which pins are pulled low, how it's going to behave. Okay. There we go. Okay, so I think that's this side. Oh look, the LED has moved up to here. The LED appears to be going across from pin 5 to this pin here. So this is quite different because that, I guess, means that the LED is acting as a diode. Oh wait, that doesn't go there. That is a slightly, I need a slightly longer jumper there. Do the same on the other side. Fiddly work this. Now, I've been told by some of my viewers who've actually bought the same kit as me that they've had trouble getting it working. And if you've had trouble getting it working, let me know what you've tried and which experiment you've gotten to where it last worked, and we'll see if we can get you up and running. I mean, I can't guarantee anything, but you know what? I can have a go and see if I can determine what is wrong with your circuit. You can either message me directly in YouTube, or you can hit me on Twitter, Orion Robots Twitter, which then means in Twitter DMs or even in public, depending on how you feel about it, you can send me links and images of the circuit in Twitter. So you could perhaps send me, you know, a photo of what you've got so far and what you've tried. Now, where was that other electrolytic cap we had? Down here. And they're showing that this is parallel with the other cap, with the negative line going out to the speaker. Oh no, see, one's going to the speaker, so we'll move that down a block. Okay, so splay this so it will go across that pin and that pin. Speaker goes here. Oh, hold on. There's another one here. 1, 2, 3, 4, 5, 6, 7. Yeah, we still need another. So, day 15, expect quite a rewire. I think this is actually more suitable for this longer bridge, and this one's suitable for the shorter bridge because I've made it slightly longer. I meant that. Because that way we're not in any danger of coming short. I mean short of wire, not short as in short circuit. Because all of these connections, you've got to make sure that they are firmly in the board, and you can feel the board, so you can feel the contacts of the board gripping the wire when it goes in. And if it feels loose and that it's not quite in properly, then you could have a problem. It could genuinely be loose, and therefore you won't have a very good electrical connection. There we go, that's in. Okay, right, that's that side of the board done. So just double checking. That goes up there. See this connection? There's enough that it's in. That's okay. Good. All right. So we'll come across to this side of the board. I'm going to need some light to see. So we've got 1K from this pin to 5. One of our caps. That is going across there. See if I can actually see now. Those almost appear to just be stored because they're not actually wired to anything. Look. So they appear to be just being stored there, but maybe they're being prepared for whatever the next day's circuit is. Okay. That one definitely goes up here. It's an interesting little network they've created there, but I can't tell if it's for anything, or if indeed it even matters. No, they didn't store all the other components when they weren't in use. They just kind of left them in the box. So maybe this is preparing for something tomorrow, but these aren't wired into anything else. They're not wired to power, not wired to anything else. They appear to be just being stored up there. So it's only really this side of the board that matters. Those components, although there's a wire here, that wire goes across to this line. That wire goes across this line. Nothing connects that patch. Preparation. Right, let's connect it then. So I've gotten rid of the resistors. The resistors and capacitors here were being used with this variable resistor potentiometer to make the sound and to complete the oscillator circuit. They've gotten rid of those. They've got a bypass capacitor here, store of energy and smoothing for the op amp or audio amp. And they've got this capacitor, which is, again, energy and smoothing for this. They've got one capacitor resistor circuit here, but what I no longer see is there's no longer the feedback that we had before. So that, I think, is because all the oscillation now is being done by this chip, the 8051, some code running on it, which means all these resistors that were doing the timing are out. So it's all coming from here. So I'm expecting still to hear tones, hopefully. Oh, let's move that where it's a bit less. It's quite loud. And do we still have the... So this appears to be changing. It says control the volume. Due to the very high output signal of the processor, yes, my ears are ringing, the control range is relatively small. 2 different tones are generated in turn. And yeah, these did change the... so it says you can control the speed, which is the case, so I can control the speed of the sound change. So the instructions are working. It's coming together. I suspect we're preparing to be able to use this for far more, and we've kicked it into a different mode, because before it would have been pulling down the pin that would have changed or put the other resistance in series here, or not. Now that's no longer happening, and although these are causing the same change in rate, instead of pulling down that pin, it's now outputting, I suspect, the tone directly on this pin. So that pin's outputting the tone. That potentiometer's down to 0 there, so we're going between 0 and the tone across this capacitor, which will take off any DC on the input to the audio amp. So this is going to be inputting to the audio amp here. That's just a bypass cap. That's still our audio output to the speaker. Cool. But what that means, if this is generating the tone, we'll get to be able to use it to generate, well, I guess far more different tones and other sounds from the processor itself. I hope you've enjoyed this slightly extended Advent day for the electronic sound calendar, and I hope to see you tomorrow. So go make stuff and be awesome. Bye.